Welcome to the new episode here at Big Ideas in App Architecture podcast, everybody. Today, I have with me Tomer Karin, who is a software architect with some fantastic, working experience in the automotive software development space. And I got introduced to Tomer on LinkedIn, and you had some really great articles talking about this new evolution of automated software development with transformation from CI/CD to CICS, and you put these articles together, I think, and that's how we got connected. And we've been trying to put this thing together for a while, but it's been a little bit of a busy schedule. But thank you once again for joining in, Tomer. I really appreciate you coming in.
Thank you. It's my pleasure.
There is the application stack, right, which I look at it as a triangle, and the developers have to write code, and then they have to basically write a workflow, and then the workflow basically in the simplest way gets checked in to GitHub. And as soon as a new code gets checked in, you have GitHub actions that gets triggered. And this is like a typical CI/CD workflow that we are used to. Sometimes you would write like the build and push, and sometimes you would like the deploy. So in between, there are a bunch of different things and different tests, integration tests, the build, end-to-end testing that all has to happen. And from your perspective, in the traditional CI/CD workflow, what used to happen was when somebody used to do this, there would be stuff that would break, and then you would come in the morning, you have to figure it out, and then there are issues related to that because it delays us, right? Like, so it has happened to me many times. I would check in a code, and I would hope this build will take like 2 hours, then it'll come in the morning, it should be all green. Never happens. And then you are talking about this future where instead of us going through these iterative process and going back and looking at what needs to be fixed, we have continuous solutions. That means when the deployment breaks in the CI/CD pipeline, there's some sort of a trigger that looks at these logs, and then it basically goes and corrects the issue that caused that, basically in an intelligent agentic way. I know obviously we are kind of talking about it soon, and then we have this continuous integration and continuous solution. So we go away. We are looking at a new way of software development in this application stack. Did I understand that correctly?
Yes. I can give you a little bit more details about how it used to be, in which you described pretty well. But I don't know if many of our listeners understand what CI/CD, so I'll give it a little bit more explanation, and then I'll explain how it does it. So basically, CI/CD stands for continuous integration and continuous delivery or deployment. But basically, what it means is that, in simple English, is that engineers write the code, and then they push it to the share repository, and then there is automation pipeline that builds the code and starts to run the test, the pipeline of the test. And if something fails, usually the pipeline stop at least the test that failed, and reports the failure using logs. Okay, and then the humans sometimes have to come and see all the logs that were failed, investigated, and fix the issue. So basically, the CI/CD is very good at answering one question: did the change that we committed the evening before break the code, and was it functioning according to the design? But the problem is, as we mentioned before, is that when we're working on a very large scale system, there are so many tests that statistically the pipeline fail constantly. The failures sometimes can be repetitive, and the main problem is that the root cause analysis many times take far more often than actual fix. Okay, so because it's such a complex system to understand what was the root cause. Oh, this is the root cause. I fixed it in a second. No, but it took me 2 hours or 2 days or 2 weeks to understand the root cause. Okay, so then what I did when I thought about this ideas, and I think that the main idea is, if you use AI every day for the software development, what if the system itself could take responsibility for recovering the failure, for analyzing it and understanding it? And this is exactly where the CI/CS, the continuous solutions, begin. Let me explain how it works in practice, okay? So when the CI/CD pipeline fails, the failure is passed to the AI agent. then the agent does the following. Okay, and it analyzes the failure and the logs and the error traces. It
Yeah.
correlate them with the recent code changes that it received from the GitLab. This is integration both with the GitLab, that you have to know what was the changes, identify the root cause of the problem, and understand how the problem was introduced. Okay, what caused this problem? Okay, once the root cause is understood, then the agent does the following: it rewrites the code, and which will fix the issue. It should report the bug and fix to the Jira, because every fact has to be fully documented. It creates the merge request, and it reruns the entire CI/CD pipelines. And basically, the main issue about the CI/CS, one of the main issue, is that it does it without any single human in the loop. Everything that I just described happened usually while you sleep, and you come in the morning and you see that the core difference between the CI/CD reports failure and the CI/CS basically resolved them.
Yeah, this is amazing, because I think one of the most interesting things about what you said is that that I really appreciate is that, and anybody would relate with that, sometimes to fix something super simple, we will take hours to figure out what caused that, right? So it's like a whole process around root cause analysis. But at the same time, you also mentioned some of the challenges developers have. We have to create a Jira ticket. We have to put all the documentation. We have to go through the process of putting screenshots exactly what happened. Might be something really small, sometimes it might be bigger, and then you have to do all of these things, and these things can actually take over the actual outcome that you want to drive as a developer, that is just push the code and make the application to work. To your earlier point, when you build large complex applications that have significant impact to the enterprise and to customer base, you cannot just have this cookie cutter rudimentary simple approach to like fix stuff. You need to document it. You need to make sure there is a way to observe what has happened and learn from the things, and so that even the agent can learn from, even the copilot can learn from. So can you broaden, if I have to implement CICS in my workflow, what are the kind of tools I need to use, and what is it that I need to set up to make sure that this works in an automated way?
So we need to find a new way to do it, and we need to have some Python programmers. And today, I think that most of the people does not write code Python by themselves. They use the AI to do it. But so we have to write scripts that will actually do it for us, and will connect some kind of an open API or a Cloud API or whatever API using Python, and it will give it the logs that we found, which is, the CI/CD easily can give us, okay, this is the failure, this is the log that failed, do whatever you want. But I want to stop being the one that analyze this log. So I have to create interfaces for the API for using Python script to send it to the LLM to analyze the log. But then there was another issue, because the logs might be, I don't know, 12 megabytes and even bigger, and you cannot, if you give the LLM such big logs, you burn all your tokens. It'd be very, very expensive. So you have to write a Python script that will make the log shorter, and it will pinpoint the actual error inside the log. And a lot of logs, there are many errors, so you have to do priority for those errors. There's a lot of scripting that is involved, and you have to get these abilities. And later on, you need to do something that was not done yet, which was taking those LLM and give us the abilities to integrate with GitLab and with Jira. And a lot of people use MCP to do it, and then the LLM can access them directly. But this burns a lot of token, and it gives not accurate results sometimes, because sometimes the LLM does not really understand it. So we have to use REST APIs in order to integrate with the GitLab or GitHub or the Jira or whatever. So there's a lot of coding that need to be involved and a lot of integration effort that need to be done. But the main thing that pushes forward, I think, is the vision that it can be done. And when I introduced this thing to my colleagues, some of them laughed, some of them told me, okay, the AI is not there yet. It will take years until it will reach it. But eventually, with a lot of belief and vision, we made it happen.
Yeah. I mean, what you said is, you will see a lot of people who have gone deep with using good systems with AI starting to bring up these concerns. And actually, what you said, and even for audiences who is listening right now, what Tomer mentioned is actually a real problem, right? Yes, you can use MCP. Yes, we can use bunch of these capabilities, but you're also burning down tokens, and it's extremely costly. And I'm noticing a pattern in the industry, especially with Anthropic recently. I don't know if you followed. They donated the MCP protocol to the open source community, effectively making it more open source. But there is a paradigm where people are shifting back to using REST APIs because it's much more effective on the overall cost optimization related to using AI in these kind of workloads. So I think what you said is a very, very, very valuable point for people who are trying to build these systems. So, and obviously you had the vision to make sure this kind of workflow works. So I wouldn't be surprised if other people discover this in their discovery process as well.
Yeah, I think that there are probably many other groups around the world that are working towards such a solution because, as a developer, I was, I don't know, 2 decades a developer that wrote code, and my main issue was um, I want to deliver new code and to deliver new features, and always the bugs were the ones that stopped me. And I came in the morning and I was planning to do a new feature development that I was thinking about for the last days. And eventually, but I saw the red test, and basically I knew that my day is ruined because I'm going to investigate all my day in fixing a problem that might be very, very frustrating to fix or to recreate and to find the root cause and how to fix it, which will also delay my intentional plan to deliver the code by the end of the week, and then I have to work late hours, and it's very frustrating. So I think that most developers today use, I don't know, maybe 50% of the time in code fixing, and if there's such a solution that can minimize it to, I don't know, an hour a day or half an hour a day, I think that that's the way you work, and probably many other groups around the world are trying to accomplish this mission. I saw that it's possible, and it's a vision that is coming true.
100%. Yeah. And I think what you said makes sense at scale, right? Like when you have workflows and systems that have thousands of tests, it's not like a small GitHub project where you just submitted and hoped everything ran. You're talking about implications to the actual business as well. So you have to consider how the developers are spending their time. It is also interesting what you said, just philosophically, where the space is. We are noticing, especially, I mean, I was talking to somebody else the other day who was saying that we thought like AI would be able to like do some things, but it'll take some time for it to get good. But I feel like in the last like 2-3 months, it's suddenly become really good with like Opus 4.5, Gemini Pro 3. I think it's showing some significant efforts. And I was talking to them, and I was telling them I feel like I'm slowly becoming an agent manager. Like I have a bunch of different agents, and I'm just managing them, and I'm making sure that these guys are working effectively. Uh, when these agents that you have built, who read the log and find the bug and fix it, um, what is the human's role in that? Is it just going back and looking at what was created in the morning and verifying that these fixes make sense? Are you concerned about the quality of the code that the AI might be creating to fix these things? Or maybe there was a much more efficient way to do it and it found a way to fix it, but maybe it was longer. So do you have those kind of feedback loops set into this system that you feel that we should be looking at?
Basically, it's a good point because even yesterday I was writing a new software model that I need to create, and I saw that when it got too complex, then the LLM model which I was using need to be instructed like a junior, and it was very frustrating because I spent 3 hours and of doing agent prompt debugging, and each time it did not give me the results I wanted to, and then I have to tell him exactly what to do and why the fact that he's doing it here and there, and have to fix it. And it was very, very frustrating because, first of all, I thought to myself, oh, maybe I should pay for a better LLM, which is more expensive. Maybe it will fix it to me. So I tried it, and the results were not that better. Okay. So, and then I tried to improve my prompt and to show him pinpoint exactly what went wrong. So that brings me to the main issue. We need to have a very strong guardrail. Okay, we have to do the supervision of the code much better. Basically, the AI outputs must be checked using deterministic validation rules and multiple verification layer. It's not enough verification layer that we had before. We have to thicken them because some or many, or we tend to trust the AI, but we don't understand that it might deliver very bad code, and in a complex system, it's very hard to crack. I developed a relatively small model which gives a very straightforward output, but I need to investigate each and every output to see it's okay. So we have to make sure that errors are caught early, and we have to also make sure the AI permissions should be strictly limited, and the most important thing is that AI must never review or approve its own changes, okay? So the humans must be in the loop, at least for the supervising part. So, and in autonomous driving, of course, all the safety-related changes required human approval. The AI can assist the development, but human must remain responsible for the safety critical decision and for all reviews, even if it's not safety critical. So we have to strengthen the way we do the review, because when I review my colleague or my team members, I know how he work. I know he have responsibility for the quality of his code. I know that I need to supervise him, and I know that if he see an error, he will fix it, and I know that how good he is in testing his own stuff. But the AI is not, unless you told him, is not writing his own testing, is not reliable. He will not. He will fake without even telling you that the thing that he wrote was wrong, and you have to find a better level of verification, which need to be created in order to be able to trust more the AI. So the AI is a very good tool, but the verification for it must be also tougher.
Yeah. No, I agree with you. I think some of my experience is like the if you are trying to build code that you expect most of the companies to kind of have built already, or like for example, if you trying to build a web page or some sort of a simple application, you will notice that something like that has been coded in the space. So these large language models have been trained on that code, so kind of are familiar at spitting out a similar code. However, when you go into deep complex, like if you're trying to ask a large language model to write a fully fleshed database where you have to go into complex logic and code, or you ask it to write a full vision model, you will see at some point it'll start to burn out because it's not intelligent enough to kind of think like how a human looks at a problem and go to that point. So I definitely, I think it's a well said point that it's a great tool that needs to be adopted, and it's also like changing the way we kind of you do architecture, right? So from your perspective, how is the role of an architect changing, in the sense like now we feel like you're going to become like become a automotive architect. So how do you see this role kind of growing and changing in the age of AI?
So when I'm thinking about the AI and how the AI can help the architect, what I see is that every day I find new ways to use the AI. And I think that the most common three ways that I can think of is one is the requirements and architecture generation. You know, I have to write a lot of software requirement and software architecture items, and basically the AI can analyze thousands of stakeholders' requirements stored in our ALM system, like Polarion, Kotlin, or those, whatever ALM we were using. It can use a MCP in order to access them. And basically, the AI can help us understand what the stakeholder requirements, and it can guide and we can guide the AI to do the following, like generate system and software requirement analysis, create the architectural design document, automatically include, for example, the ASPICE compliant best practices inside our documentation. We can we can ask the AI to add verification criteria, complicity matrix, and create the traceability links, which is, for example, very useful if we do out of context development, where you develop the system before the client was there. But those outputs still required manual review. This approach drastically reduces the time spent on the documentation and improve the process consistency, but the human must supervise it. Okay,
Right.
So it will take, I don't know, 2 hours for me to write the 2-page requirements. Okay, according to the stakeholder requirements, software requirements, but it will take me 5 to 10 minutes to review requirements generated by the AI and make sure they are consistent with the stakeholder requirements. So it's a magnitude of time that it can save us. Another thing that takes me a lot of time, I need to draw architectural dynamic views, which means flow chart, sequence diagram, and activity diagrams according to the design I create. And I can see that the AI can easily create, there's a diagram language called PlantUML or Mermed or whatever language you use, and the AI can easily create them and do it for me. And the only thing you need to do, okay, you see the flow chart and say, oh, this is exactly what I wanted. I don't need to draw this line exactly to the center of this box or to this decision chart. And the AI do it for me, save me the 2 hours that will require me to do this diagram. I just have to review it. But I think that the most important part that the AI gives me as an architect is something that I never had before. Okay, this is the design verification. You know, when you're a developer, you have some code review to do your code review analysis, and you have all the testing, integration testing, quality testing, the code that you did exactly what you intended to do. But as an architect, I don't have such thing. So what I can use the AI for comparing documentation and implementation, across multiple layers, for example.
Right.
Take the code design from the GitLab, GitHub, wherever repository lies on, and compare it with the software detailed design documentation. Okay, we tell the AI, this is a code, this is a little design, find the mismatches. Okay, now we can show the SDD detailed design document is aligned with the software architecture. We give you this document, you give this document, tell me, okay, where there's the mismatches. So detecting misalignment between evolving requirement, implementation, and when you think about it, where you have multiple teams contribute hundreds of thousands of lines of code, this level of continuous validation was nearly impossible before. No, the time to read so many documents and to give you the mismatches. Of course, you need to review each document, but as time goes, you can do as a part of the nightly tests, okay, add documentation verification and design and code according to design verification. This was never done before. There was never a tool for it, only a manual inspection. But when you have dozens of developers to develop the code, the architect cannot follow each and every change they do and make sure that they didn't go not according to the architectural design. So this is something that the AI can definitely help us.
Yeah, no, absolutely. And I think what you said, I mean, there are a lot of details you shared in that, right? Like typically when you look at like any architect who's working on these things, there were a lot of manual stuff, but that's changed, right? And I think what is very clear in this conversation and all these recent new progress is that it's significant what AI is able to do and support us with, right? But there are also implications of using that, right? So we have to consider, what is the economic impact of CICS on software development? Are we talking about, hey, I just need like maybe less number of engineers now to do these things, or we can have the same number of engineers and do more? Like those are some interesting ideas. But before we go there, I wanted to ask you, for companies who are trying to adopt AI into their systems and into their practices, if they want to build this, a trusted AI driven CICS pipeline, what do you think are the challenges right now that they have at a cultural level, at an organizational level, that might hinder them from this success, and how can they overcome that?
Basically, yes, it also returns to the previous question that you cannot trust the AI, okay? And that's a very big step that we need to overcome in order to be able to do something that CICS actually fix our code and change and generate our code for us automatically during the night. It's insane. So it's a totally new concept. So in order to achieve this, what the team must do is, first of all, start to trust the outcome of AI, and I'll explain later on how this is possible. We need to demand transparency from AI. We need to get full reports how this outcome that the AI gave us was achieved, and we also accept the idea that the machine initiated the change. Okay, changes our code over the night. Something that it's different than when you give a prompt and you actually see it. When you come down in the morning and you see all the changes, it's a totally new concept. So basically, the trust comes from visibility and control. But the AI needs to prove itself. Like, for example, the way we did it in order to start to trust the AI to allow him to run the CICS is showing it solves bugs, which we already solved by humans, and we wanted to solve it either in a similar way or in a higher quality. So only after we reach this step, in many cases, and for other organizations can start trusting that the AI can achieve similar or better than human results. Before we actually testing it on known issues, we cannot give him newer issues to fix, because then we are going on a very risky ground.
Well said. I think one of the things that we also have to consider, as I was just talking about, is the implications of CICS and software engineering and how it impacts like the economics of software development, right? And so as we close, I mean, we've been talking for a bit, and I know it's late for you, but it's been a fantastic conversation. How do you think CICS changes the economics of software development? And also, we're going to make some bold predictions. How do you think automotive system software development is going to look like in 5 to 10 years? Are we saying fully autonomous pipelines? Are you saying AI first architecture design, or maybe a continuous iterative process where humans are involved, just like how we are today, but maybe our role changes to say 10-20% and 80% of it is done by AI?
The best thing about it is that with CICS, many of the bugs are detected and fixed early and automatically. Okay, this removes a large part of the trial and error work from the development process, and as a result, the developers are free to focus on what they do best: building new features and creating values, rather than constantly fixing bugs, which is very frustrating. Okay. And over time, if you ask me, the prompt-based development and the AI system coding will become the standard practice. Like writing low-level code, and I'm saying like Python is a low-level code by hand. It will still exist, but it will be needed less often. Just like to how assembly programming exists today, but it's handled by a small group of very highly specialized experts. Okay. And I think that the biggest economic impact comes from the fewer late stages surprises, which are very pricey to the company, and much less firefighting. Don't need to stop the fires. Team will spend less time reacting to problems close to releases, and will have many times delivery which are coming on time, which are predictable, and the clients will be definitely happy if we are giving them on-time delivery. Developer can work on multiple projects, will be able to move faster, will maintain high quality with the same or even smaller groups, less firefighting, as I say. Developer will be able to deliver on time. Now,
Right.
when you asked about the what will become in 5 to 10 years, comes with uncertainty. But I think, and this is only my opinion, okay, is that I think eventually software pipelines will likely to become high autonomous, but still supervised. I don't think that supervision can be taken from the pipelines. The automation and AI will handle most routine decisions, while humans remain responsible for overnight accountability and critical approvals.
I think I also agree with you in some of the things that you've said. I think most of this, I expect this to get a little bit more AI heavy, but with a supervised kind of motion, right? I feel like most of the things that we do today will get automated, and then we will need some sort of a supervision to make sure that everything is working as we need to. But we'll also find so much more creativity as humans, right? Or developers. Like it'll unlock us to do different things that we want to do, instead of, as you were saying, firefight and figure out what needs to be set up. So I do feel very optimistically about how AI gets adopted in these pipelines. And it was a pleasure just to talk to somebody who is talking about the CICS piece, because I do see a lot of people, Tomer, talking about how AI is great. And if you're doing agents, we can do this. We have to build data centers in the space. There's a lot of different things. But what you are talking about is an actual problem that developers face on a day-to-day basis. And you're talking about applying that in a very, very constructive way to solve and accelerate, software development in a very progressive way. So thank you so much for, coming on at this late evening and, sharing your perspective. I absolutely love the articles that you're writing and the spirit with which you, write these articles, and the passion to give back to the community and to the software development space. I highly encourage you to do more. And we absolutely loved having you on the podcast today. So for everyone listening in, go find Tomer on LinkedIn. It's Tomer Karin. And you'll find embedded software architect over there. Follow his articles and blogs and stuff that he's writing. And I'm sure there's a book in the book waiting to be written somewhere, Tomer. I hope you have these ideas, but if not, I think it's a great concept to get into for sure.
David, thank you so much. I love to be introduced, and thank you for allowing me the opportunity to be in this podcast.
Yeah, thank you. Great.